So, example 1 and 1.4, we want to find the slope and the y-intercept of the graph of the linear equation, then write the equation of the line in slope-intercept form. So, we're going to be doing something very similar to what we were just doing, and our goal is we want to come up with an equation of the form y equals mx plus b. But we were given our line in terms of a graph this time. So the first thing we need to talk about is our b value. And recall that b is the y-coordinate of the y-intercept. So that's right here. So that ordered pair is 0, 2. So from this, we're going to get that our b value has to be 2. And then we can calculate our slope by doing our rise over our run. So if I do this, my change in y, I went up 1, 2, 3, 4. So my change in y is 4, and my change in x would be 1. So then my slope, m, would be the change in y over the change in x, or 4 over 1, which is equal to 4. So now that we have those two values, we put them into our equation, and our final answer would be 4x plus 2. So the equation of our line is y equals mx plus b, and we can count our m, or our slope, off the graph, and then we can read our b value off the graph by finding the y-intercept. All right, so now it's your guys' turn. We're going to go into our breakout rooms and work on our u-try. So we want to find the slope and the y-intercept of the graph of the linear equation once again, and then write the equation in slope-intercept form. So to do our u-try, once again we need to identify our m and our b. So the b is the y value of the y-intercept, which is right here. So our b value is going to be -1. And then we can count our slope off. And if I go down 2 and then over, or down 3 and over this way, that gives me my delta y is -3, and my delta x would be +6. So then my slope would be delta y over delta x, which would be -3 over 6, which reduces to -1/2. So then the equation of my line would be y equals -1/2 x plus our b value in this case, which is -1, or we can just write that as -1. So this problem really is just putting together all of the stuff that we did in our previous section 1.3. All right, so let's work on a variation to this problem. So example 2 is pretty much exactly the same thing. In fact, it's the easier version of that problem because we are just given all of this information explicitly. So it says find the slope-intercept form of the equation of the line with slope -2/3 and y-intercept 0, -4. So we have m is going to be -2/3. Well, and this is the ordered pair x, y, or the y-intercept. And the reason we know it's the y-intercept is because x is 0. So the fact that we have our x value equal to 0, we know this is the y-intercept. So then our b value is exactly the -4. Well, and if we know m and b, then our answer is just y equals -2/3 x take away 4. So when we're given explicitly the y-intercept, we just drop the two values directly into the formula and we are done. So those are pretty nice. So based on that, I'm not going to open up our rooms for the U-try. But let's go ahead and write down the equation of this line. All right, we identify our m. So our m is 5/7. So it's going to be y equals 5/7 x. And then our b value is going to be this right here. So -4. So when given in this form, we really, really like these problems because they're a little bit easier to do. All right, so let's do one that's a little bit more involved. So let's take a look at example number 3. In fact, we're going to do them in the opposite order. I'm going to do you try number 3. I'm going to have you guys do example 3. So we want to write the slope-intercept form of the equation of a line that passes through the 2 points. So this is a little different than the ones we've done in the past because we weren't given the slope or the y-intercept. So in general, to find the equation of a line, we need the following 2 pieces of information. We need the y-intercept or a point. Any point will do, but we'll use it to find the y-intercept. And 2, we're going to need the slope. So let's start with the second one. If we need to find the slope, we have a formula for that. So it's y2 minus y1. So 7 minus 0 over 2 minus a -3. And we can do that on our calculator. So remember, to get the fraction on our calculator, we press alpha and y equals. And we would have 7 minus 0 over 2 minus parenthesis -3. We press enter and we get 7/5. So that's our slope. But now to find the y-intercept, we're going to use our formula. So to find the y-intercept, we use y equals mx plus b and evaluate it at a point and slope. So we have our slope that we just found right here. So our m is going to be 7/5, and then we need to use a point. It doesn't matter which one we use. So I'm just going to pick one. In general, if a point has a 0 in it, it's going to be easier, so we'll use that point, -3 and 0. So if I do that, I can put each of these in as well. So my x is going to be -3, and my y is going to be 0. So if I put all of those in, I get 0 is equal to 7/5 times my x, which is -3, plus b, which is what I want. So we used a point and a slope. And as I mentioned, if you would have used 2, 7, you're going to get the same answer in the end. Which point you use is irrelevant. You will get the same answer either way. So we have 0 equals 7 times 3, or negative 3 is negative 21 over 5 plus b. So then we solve that equation for b by adding 21 over 5 to both sides. So 21 over 5 is equal to b. Well, now I know m and I know b. So we have y equals mx plus b. So we have y equals, our m is still the same m we found up here. So 7/5 x plus our b value that we just found. And that would be the equation of our line. So let's go back and recap a little bit what we did. So to find the equation of a line, we need two things. We need the y-intercept and the slope. In the examples before this, we were given just the y-intercept and the slope, so we could just go to the very last step where we put them in. In general, if they're not given, we may have to use the slope formula to find the slope, and then we can use the y equals mx plus b to find the b like we did here. So if any of those things aren't given, we're going to have to do a little bit of extra work in order to get those values. All right, so to work this problem, once again, we need to know the slope and the y-intercept. And what we'll notice in this first point, we have our x value is 0. So then that means that this is the y-intercept. So if that's the case, then this is exactly our b value. We get that b is negative 4. So then we need to find the slope. So we're going to have 3 minus 4 all over 6 minus 0, which gives us 7 over 6. So then that gives us y equals 7 over 6x take away 4. So as many people talked about, they actually used that point, or one of the 2 points, to find b. And did you end up with the same b value of negative 4? Absolutely. So while we may be able to do these problems multiple different ways, that's fine. Sometimes there's a faster way. But one thing I want to emphasize is that I'm goal-oriented and not path-oriented. And what I mean by that is if you're using a correct method, whether it's that point, recognizing it, or something else, I'm going to give you full credit because our goal is to get from A to B. We can talk about being more efficient and doing some of those things as we go along, but to become more efficient, you first have to be proficient, which means you have to be able to get an answer before you can worry about optimizing or making the process more efficient. Okay, so multiple different ways to get from A to B. All right. So let's take a look at our next example. So example number 4 reads as follows. Write the equations of a horizontal and a vertical line that passes through the point 3/4, negative 1/2. So thinking back to our last section in Chapter 1, Section 3, we had 2 observations. So we had for our horizontal line, had the form x is equal to a, and our vertical line was y is equal to b. No, I have those backwards. I am so sorry. Horizontal line is y equals b, and our vertical line is x equals a. So just to be very clear, I wrote them in the opposite order. Horizontal lines are y equals b, and vertical lines were x equals a. And on a horizontal line, we had the following: y does not change. And on a vertical line, we had that x does not change. Well, with those key observations, if x does not change, what would my x value have to be on the vertical line? Well, if it can't change, what's its only choice for it to be? 3/4. Similarly, on the horizontal line, if y does not change, what's its only choice for what it can be? -1/2. So then our two equations are y equals to -1/2 and x equals to 3/4. So whenever we're talking about finding the equations of horizontal and vertical lines, they're two special cases. They have a different way of doing them, and it's exactly this. The key observations were these two things here. That on a horizontal line, y doesn't change, so it's y equals whatever the y value is. On a vertical line, x does not change. So x has to equal whatever the x coordinate is, because they weren't allowed to change. And in that formula, the other coordinate can be anything that it wishes. All right, so for the U-try, I'm not going to put us in rooms, but I want you to go ahead and write down the equation of the two lines. So the vertical and horizontal line that go through the point 2, 7. All right, so what is the equation of our horizontal line going to be? Well, since on a horizontal line, the y value doesn't change, our y value is 7. And for our vertical line, on vertical lines, x doesn't change, so our x value has to be 2. All right. Now I have some definitions we need to write down. So in geometry, we say two lines are parallel if, when extended, infinitely in both directions, the lines do not intersect. So geometrically, in terms of a picture, we'd have two lines, and if we extended them infinitely in both directions, they would not intersect. Well, we're not in a geometry class, we're in an algebra class, so we want an algebraic definition. In algebra, two lines are parallel if and only if they have the same slope. So in symbols, m1 equals m2. So in terms of our lines, if this had slope m1 and this had slope m2, their slopes would have to be equal. And if you think about that, if they have the same rate of change, they're going to have the same rise and the same run. And they will never get any closer to each other, no matter how far we go in each direction. We have another one that we want to talk about, which is perpendicular. In geometry, we say two lines are perpendicular if they intersect at a right angle. And a right angle means a 90-degree angle. So in terms of our picture then, we would have our two lines, and they would intersect, and specifically, they would intersect at a 90-degree or a right angle. In algebra, two lines are perpendicular if the product of their slopes is -1. So in symbols, m1 times m2 is equal to -1. So if this line has slope m1 and this line has slope m2, if you multiply their two slopes together, you will get the value -1. So some of you are probably saying, well, hey, I've heard something a little bit different, and this can be rephrased as their slopes are negative reciprocals. So in symbols, that's m2 is equal to -1 over m1. And notice these two definitions are exactly the same, because if you have m1 times m2 equals -1, if you divide both sides of that equation by m1, you get the second equation. So it's really just a rephrasing. They're two equivalent things. And so using either one will give you the same correct solution. All right. So once again, I'm going to do you try number 5, and then I'm going to let you guys do example 5. So determine whether the pair of lines is parallel perpendicular or neither. So to go ahead and get started on this, the first thing we need to do is find the slope of each line. So once again, the lines are in standard form, so we need to solve for y. So we would minus 5x and minus 5x. And that gives us 3y is equal to negative 5x plus 11. We divide by 3, divide by 3, divide by 3. Finally, we have y equals negative 5 over 3x plus 11 over 3. So now that we have it in this form, we can identify our m for this equation. So it looks like our m1 value is going to be negative 5/3. So now we rinse and repeat, and we do the same thing on the other one. We have 3x minus 5y equals 1. We minus 3x. We minus 3x, and we get negative 5y equals negative 3x plus 1. Divide by negative 5, divide by negative 5, and divide by negative 5. Y equals 3 over 5x minus 1/5. So we compare over here, y equals m2x plus b. And so we get our two different values. So our first slope, m1, is negative 5/3. And our second slope, m2, is 3/5. So now we go back to our definitions. So to be parallel, what had to be true? So for parallel,
the slopes had to be the same?
So parallel, we have to have m1 equals m2. I really need. So does m1 equal m2? And the answer is no, so they're not parallel. For perpendicular, we want to know, well, does m1 times m2 equal negative 1? Well, let's find out. We have negative 5 over 3 times 3 over 5, which gives us negative 15 over 15, which equals negative 1. Check. So, yes, then the lines are perpendicular. You may have noticed, without doing that computation, that negative 5/3 and 3/5 are negative reciprocals. The reciprocal of a fraction is where you reverse the numerator and denominator, and then the negative is you change sign. So if you do that, you would see that the reciprocal of negative 5/3 is indeed the same as 3/5. All right. So if both of these would have failed, if they're not parallel and they're not perpendicular, the only thing that's left to choose is neither. So in the homeworks, you will see all three of those choices: parallel, perpendicular, or neither. All right. So the next one is for you guys. It's your U try. All right, so this example, we need to identify our slopes. So the slope of the first line is 1/3, and the slope of the second line is negative 1/3. So our first question is, does m1 equal m2? And the answer is no, so they're not parallel. for perpendicular, if we multiply them together, 1/3 times negative 1/3 equals negative 1/9, which doesn't equal negative 1. So perpendicular is also no, so it's neither. So the one thing that was a little tricky about this is it was almost too easy. Some of us may have wanted to try to do something to find the slopes instead of just read them off. So just be a little bit careful with that.